pK is a constant value depending on temperature. It changes with temperature. Otherwise, it's a constant value. All right, it has to do with affinity, connection, attraction between chemicals. For our body temperature, that number happens to be, I think it's 6.1. I'm going to say 5.1. I think it's 6.1. Let me double check. I reviewed tonight. You've got one. Yes, 6.1. So for our body temperature, normal body temperature, that number is 6.1. All right. Plus the logarithmic value of our bicarbonate ions. And our amount of carbon dioxide, okay? It's actually, the value is really for the hydrogen ions, but we don't measure that, we take labs. And so instead, we take the partial pressure of carbon dioxide, remember it's usually around 40 to 45, and multiply that by 0.03 in replacement of our hydrogen ion concentration, okay? So in other words, hydrogen ions versus bicarbonate ions, that's what we're looking at here. But because we don't have a standard lab test for blood that measures specifically hydrogen ion levels, pH, but not hydrogen ion levels, then we use our carbon dioxide, okay? So, when this ratio, whatever those values are, and comes out to, we'll look at them in just a moment, comes out to 20 to 1, let's put in our logarithmic calculator here. All right, so on this thing you can switch from logarithm to anti-log. So I have it on log, and I'm going to put in 20. 20 divided by 1 is 20, right? It comes out to, I don't know if you can read it, 1.3. So when our ratio of bicarbonate ions to carbon dioxide is a ratio of 20 to 1, the log of that value is equal to 1.3. And when we add 1.3 to 6.1, you get 7.4, which is what I said was the normal middle of the range of our body's pH. All right. So I'm going to toggle back and forth between this and our component. So here are the, so if you look in your lab packet, the normal bicarb, let me put this up higher. Normal bicarb values are 24 milliequivalents. Okay? That's in your lab packet. Normal arterial PCO2 is, anybody remember? As the blood is leaving the lungs, what's our CO2 value? 40. It's 44 when it's coming back in the veins. So when it's down in the arterial value, our normal is 40. All right? So if we put 24 up here for our milliequivalents, and we take 0.03 times 40. I knew I brought my phone in here for a reason. All these messages about Thanksgiving dinner, I can't deal with this. It's plug in our normal values for bicarb. Our normal bicarbonate values are 24 milliequivalents. Everybody with me? All right. And our normal arterial PCO2 is 40. Then we end up saying 24 divided by 1.2, and that equals 21. And when I take the log of 20, because 20 divided by 1 is 20, when I take the log of 20, I got 1.3. When I add 1.3 to 6.1, I get 7.4. Okay? That's where we get our normal pH. We look at those values, and when you test the blood, that's what the pH comes to be. Because these buffer each other out until we get to the point where we have a pH of 7.4. Okay? So if I give you a problem, Jackie, CO2 in her blood is 40, that's normal, right? Her bicarbs are 38. So we're going to change this number to 38. What's 38 divided by 1.2? So what do I do next? I go to my calculator and I take the log. So first of all, would you expect this to be acidic or basic pH? So does she have too much bicarb, or does she have too much carbon dioxide? She has too much bicarb. Is that going to make the pH go up or the pH go down? Up. So what was my number again? 31.67? And it's 1.5. So instead of a pH of 1.4, our pH is now going to be, a pH of 7.4, our pH is now 7.6, and it went up. So our pH is 2, basic. Okay? You see how I did that? All right, so if you look at the assignment on the extra credit portion, I have, I think, 3 or 4 patients that I asked you to find their pH. Okay? And these are on these PowerPoints that I'm going through are on Canvas. So you can look at them for directions. All right, but before we go further and look at how we find the bicarbs and how we find the PCO2, sometimes we have to look at the anti-log. Let's look at that 20-to-1 ratio a little bit more, okay? So may I erase it from the board? All right. So in our normal ratio, 20-to-1, meant we had a normal bicarb, all right, which is 24, and we have a normal PaCO2, which is 40, all right? This number represents metabolic conditions. This number represents respiratory conditions. Okay? So let's say somebody has pneumonia. They're not able to ventilate their lungs very well. What's going to happen to the CO2 in their blood? Is it going to go up or go down? It's going to go up because they're not moving it into the alveoli where you get off. So if you see a condition where the number changes like that, just those facts alone, without knowing the pH, tells you that it's a respiratory problem. because our metabolic numbers stayed the same. And our respiratory numbers went up. So is this gonna result in acidosis? Is our pH gonna go down, or is our pH gonna go up? Are we gonna be making too much carbonic acid or not enough? With additional CO2 in the blood. We have extra CO2 in the blood, that's gonna make more carbonic acid, that's gonna release more hydrogen ions, so our pH is gonna become lower. So when you see a number here where the respiratory value has gone up, this is a case of respiratory acidosis. Okay? Does that make sense? Okay. Because our level of CO2 is almost doubled. Instead of 40, it's around 70, 65. Too much PCO2. Okay? Now, what about if this number is lower? Maybe you're standing, you're climbing, you're hiking at 8,000 feet, and you're trying to take in deep breaths to get extra oxygen, but you end up breathing off too much CO2 because of your deep breathing, trying to get additional oxygen. You breathe off your CO2. So now your CO2 levels are too low. What about your bicarb levels? Have they changed? No. So this is still a respiratory problem because it's our respiratory number, our CO2 value number that has changed. All right? So it's still a respiratory problem. But now we don't have enough carbonic acid to balance out the amount of bicarbs we have in the body. We have too many bicarbs for the amount of hydrogen ions we've formed from our CO2. Does that make sense? So instead of being respiratory acidosis, we're now in respiratory alkalosis. Okay? So you don't even have to see that ratio. What if I told you our bicarbs were 24 and our PCO2 was 25? You can tell that this is normal and this is low. So it's still going to be respiratory alkalosis. Okay, so you can tell by either using the actual lab values or by the ratio. Okay? So you don't have to convert this into a 20 to whatever, you can just look at those values. All right, so now let's use the bicarb values. Now when we do our ratio, CO2 is fine. CO2 is 40. All right? But instead, our bicarbs have increased. Too much vomiting. We've lost hydrogen ions. And so we have more bicarbs in the body than we have hydrogen ions to buffer them because we've lost them through vomiting. So our bicarb number has changed. So this is a metabolic condition. Is it going to be alkalosis or acidosis? Alkalosis. Alkalosis. Okay? Now, let's say we've lost bicarb. Remember that diarrhea I was talking about? This could also be Tums, too much antacid. Okay, now let's say we've lost the bicarb through diarrhea, or you're in ketoacidosis. So we're going to make this number, instead of 20, we're going to make this number 15. Respiratory is still normal. So this would be having, say, a bicarb of 19 and a normal PCO2. So we don't have enough bicarb, but it's our bicarb that's the problem, not the CO2. So again, it's metabolic. We don't have enough bicarbs to buffer the amount of hydrogen coming from our carbon dioxide. So it's bicarb, metabolic rather, acidosis. Okay? Does that make sense? All right. Two more sets of changes. So this was our normal value, right? And I said when we went from 20 to 1.8, that was respiratory acidosis. hours later, and we're drawing labs, and we see wrong way. We were respiratory acidosis, and yeah, I did it right. We've increased our bicarb, okay? So we increased our carbon dioxide by almost 100%, by 80%. We increased our bicarbs too, so we're slightly buffering it. It would improve our pH, but it wouldn't make it back to 7.4, okay? So this is called respiratory acidosis, but partial compensation. The body is retaining bicarbonate ions, our beta cells are reabsorbing, our hydrogen cells are increasing hydrogen ion secretion, and we're reabsorbing bicarbonate with our alpha cells and our proximal convoluted tubule. So we've slightly increased the normal value, but not enough to completely bring us back to 7.4, all right? So our pH is not going to be 7.4. If it was, it would be fully compensated, and I would know what the cause was. So we'd be back to 7.4, and these would have changed equally. So for instance, without the math, if my PCO2 is 2 instead of 1, and my bicarbs are 40 instead of 20, I'm fully compensated. I still have a 20-to-1 ratio. My pH is 7.4, and I don't know what the cause is, because they both change the same amount. So this doesn't tell me which one changed first. So this would be fully compensated. I could only tell what the cause was if it's partially compensated, okay? So on the extra credit, I asked you to tell me, is it respiratory acidosis or respiratory alkalosis? And then, is it partially compensated or not? I will tell you when it's fully compensated, okay? Because otherwise, I wouldn't know what it was. All right. So those are the types of questions that you'll see on the exam. I want you to know that the 20 represents the bicarbs, and the 1 represents the CO2, okay? All right, so let's look at a couple more problems. So these slides take you through the steps for working out. And we got the 7.6 that we worked out before, okay? All right, so now we want to know what the bicarbs are, okay? So the pH we do with this formula, okay? Now we want to know, we know what the pH is, now we want to know what would the lab values be for the bicarbs. So there's 3 sets of problems, 1 for pH, 1 for bicarbs, 1 for CO2. And it's just a matter of plugging what number into that calculator. All right, so the bicarb is our unknown. The pH, we know, all right? So the pH is 7.6. We have a normal value for carbon dioxide. And now we want to know what the bicarb is. We already know this is the same problem as the rest, okay? So we should come up with a bicarb of 38, I think. Or the previous one. Okay, so we plug these numbers in. pH minus the pK, so 7.6. This is a new set. We know the pH. We have the CO2. Now we're trying to find out what the bicarb values are. Okay, so there's another list of 4 individuals, 3 or 4 individuals where I ask you, I give you the different pHs. And now looking at this one, with just the data I've given you, is this going to be, looking at the pH, is that a basic or acidic pH? Basic, all right, so it's going to be something alkalosis, right? It's not going to be acidosis because our pH is too high. Is our CO2 value okay? Is that normal? Yes. So our problem is going to be a metabolic alkalosis. We can tell that just from the data you've been given. Does that make sense? You don't even have to look at a 20-to-1 ratio. Because we know that our normal pH is 7.4. And that's what I want you to deal with. Don't go up to 7.45 or down to 7.35. If it's above 7.4, it's alkalosis. If it's below 7.4, it's acidosis, not within that range, all right? So 7.6 is too high, so it's alkalosis. Our CO2 is normal. And I don't know what the bicarb is, that's what I'm trying to figure out, but I know that the 7.6 is alkalosis. So the problem must be my bicarb. So I know that my problem is going to be a metabolic alkalosis. Does that make sense? Yeah. Okay. So we take our pH is 7.6 and minus our pK, which is 6.1, all right? And that gives us, that's what we take the analog of, okay? So that you need to follow, or else you come up with the wrong thing. If you try to take the analog of this, it's not going to come out right, okay? So that's the tricky part of that, all right? So we take the analog of 7.6 minus 6.1. So if you go into the calculator, we can switch that over here to antilog, all right? We can use the same website, and now our antilog is 7.6 minus 6.1 is 1.5. And that number is 31.6, okay? So, that's what we put in there. 31.2, I think. And then we multiplied 0.03 by 40, and that was 1.2. Okay? So here we have the analog of 1.5, which we know is 31. I just figured it out. 0.03 times 40 is 1.2. I don't want to go too fast, okay? So I'm going to take the analog of this, take that value, and multiply it by this value. pH minus pK, 7.6 minus 6.1 is 1.5. And the analog, when I put it in my calculator, of 1.5 was 31 point, whatever, 31.6. Okay? And then so I take 31.6 times 1.2. And my bicarb is 38, which fits with what I said was metabolic alkalosis, because it should be 24. The normal value is 24. Okay? So let's stop here for a moment. Sticking with this problem, our bicarb was 38. If there is partial compensation by the respiratory system, would we be holding carbon dioxide or getting rid of it? Holding. So let's increase our carbon dioxide to 50. Okay? Now let's just run this through and see what our pH would be. So we're going to take, we don't know our pH again. So that would be equal to 6.1 plus the log of 38.03 times 50. I just want to see about so what am I doing here? I'm compensating, all right? So 50 times 0.03 equals 1.5. So 38 divided by 1.5 equals 25.3, and I'm going to take the log of that. And that's 1.4. So my pH went from 7.6 to 7.5. So I brought it down a little bit by increasing my carbon dioxide, all right? So if you were to see that, carbon dioxide was 50, how would you know it was metabolic alkalosis partial compensation? You want to look at the one that's the most different. You can just eyeball it, all right? So 50 is 10% higher than 40, if I take 10%, or actually it's more like 20% higher. And this is 24 plus 38, that's another 14, that's almost half again as much. So this has the bigger change, from 24 to 38 is a bigger change than 40 to 50. So the one that has the bigger change is the cause, the one that has the smaller change is the compensation. Okay? So this would be still metabolic alkalosis with partial compensation because this is not my normal PCO2 of 40, all right? Now, let's say that this number instead was 80. 80 is twice what 40 is compared to 38 versus 24. So now my problem is respiratory acidosis with partial compensation with the body trying to increase bicarb. Does that make sense? Okay, so you take the one that's the biggest change, and then that's the cause, and the other is the compensation. So there's no compensation if one number is normal. So if my carbon dioxide is 40, there's no compensation. My PCO2 is 24, there's no compensation. So this is 80, and that's 24, that is just respiratory acidosis with no compensation, okay? If this was 52 and that was 40, it's metabolic alkalosis with no compensation, okay? But if both numbers are different, there's going to be compensation. You just have to see which number is the most changed. And if you're not sure, what you can do is just take 38 minus 24. The number is 14. And 14 is what percent of 38? Just take a percentage difference. Okay? 14 divided by 38 is what? And then you can take 80 minus 40, and that's 40, and 80 divided by 40 is 2. That's a whole lot more than this change to that. So if you can't eyeball it, then just kind of see what percentage of change has increased. All right, so now let's go back to, so if you forget this, these PowerPoints are on Canvas. Okay, you can just kind of slide the numbers in. All right, so that was how we figured out the bicarbonates. Now, how do we figure out the CO2? So here's our CO2, all right? And I know my bicarbs and I know my pH. And I want to figure out what's the carbon dioxide level. So now we're going to take the anti-log of the difference in pH and pK times 0.03. So here's we're just using the same numbers. All right, so here's my pH of 7.6. My bicarbs are 38. Both of those are different, okay? So I know that my 38 is high, but just from looking at this, because this is abnormal, I don't know if there's compensation or not. So I have to figure out my CO2 to know whether or not this is the cause. Because I know that I'm off, and I know that this is high, but this might be compensation for the CO2 being low. All right, so I take my bicarb of 38. I take 7.56 minus 7.56. So all of a sudden I changed my pH there. Okay. 7.56. Should be 7.6. I remember changing all of this here. Should still be 7.6. No, this part is a fill in and turn in page. on your,
Oh, this, the physical paper.
yeah.
Oh.
So you're just turning in, you're just turning in that paper. I know we haven't turned any papers so far, isn't it?
Yeah.
So you're just going to turn that in. Okay, I have those close to that. So we're gonna take the 1.5. So notice, folks, it says we're taking the analog of this, not the analog of that. Okay? Catch that?
Wait, what?
We're taking the analog of this, the 1.5, not the analog of 1.5 times 0.03. Okay? So you're gonna take the analog of 1.5, which is our 31.6, and then you multiply that by 0.02. So we put those brackets in. Well, that's not what I wanted to do. Okay? So analog of 1.5 is 31.6, we multiply that by 0.03. We take 38 divided by 0.93. And we get 40. Okay? So if you look at that, so you're filling out that page and handing it back in, okay? The last couple of pages. When you get your exam.
But there's also another one, that's why, because it says there's an extra credit one online.
That's different.
Different.
That's different. Okay? If I get that one written. I don't have it written yet.
Oh, the extra credit one?
Yeah, the one that's online. So that's why I want to do this one on paper, just in case
Okay.
I don't get that online one day. Because I was gonna do it online, but who knows? I get that part to it, I get the other one.
So we 4 questions.
Okay? So the paper one, what's the page? 45. So on your lab packet, there's a printed out series of patients, and you would use these step-through components that I took you through, okay? Yeah, we're done. But she was asking the Scantron.
Oh, extra credit page
Yeah.
four.